Well, happy Sunday. This is PFG Live. Welcome aboard. Let's see. We have a bunch of people in the chat. QD Smits, who checked in, he had a run in the Netherlands, is reporting Echo Hotel Kilo Delta at 260 at 5 knots. Winds variable between 210 and 290. Welcome aboard, sir. Who else is here with weather reports? Robert Simpson is reporting 70 degrees Fahrenheit, 80% relative humidity near, but not too near, Detroit. Tuck is reporting in with 65 degrees Fahrenheit, cloudy with scattered drizzles in the Buffalo of New York. Michael Juan, welcome aboard, sir. 16 degrees science and cloudy in Edinburgh. Edinburgh. Did I get that right? Scotland. Welcome, sir. Josh, our audio check says, check. Warren Jones says Sutton, New Hampshire is 56 degrees Fahrenheit and rainy. Widgetworks reports 12 degrees science, overcast, no wind in Edmonton, Alberta, Canada, with a K. Let's see. On the YouTube side, Art That Makes Art, Wes, reporting 35 degrees and snowing. Do I need to say that again? Snowing in south central Idaho. I can't believe it. CJ Stevens says 79 and sunny in East Tennessee. Welcome aboard, sir. K-Bonk is with us. 57 and light rain in the Philadelphia. Howdy. So Windham, New Hampshire, currently reporting 53 degrees Fahrenheit. Winds out of the southeast at 6 miles an hour. And, of course, Manchester Airport is telling us that it's 10-mile visibility, light rain, overcast at 2,000, temperature 12, dew point 07, altimeter 3025. Rain ended at 09 and began at 51. Welcome. It's a gray Sunday, but happy to be here. Fun week, lots of stuff going on. I've got I've got the shop running. We're making some flat rocks. Robin just checked in with a Thai iced coffee and crispy Brussels sprouts. Ooh, man, we're all going over to Robin's after this. That sounds pretty yummy. I had my kiddo Sam say, "I will make you a waffle with sunny side up eggs on top," and I said yes, and that was my breakfast. Malteser, am I getting that right, is reporting 17 degrees science, clearing up in Nuremberg, Germany. Welcome aboard, sir. Nice to see you. Hey, Robin, I'm glad you're here because your name was mentioned many times this morning, and we'll probably mention it again. Let's see. I did lap the waffles. Taking a page out of Adam Balog's book, I did carefully lap my waffles. That's pretty funny. Paul Morley is checking in from Dallas. Temperature 23.9 Celsius, about 75 degrees Fahrenheit. Broken clouds at 2,400 feet AGL. Welcome, sir. Say hi to Dallas for me. I have good friends to your north, up in, I can't remember the name of the town, but I've eaten a lot of ribs and barbecue there. Not Denton. It's going to bug me now. I'll tell you later. We'll figure it out. So, busy week on the antenna front. By the way, I did a nice talk. At least I had fun for Frank. Frank is not in the chat right now, but for Frank's ham radio group on Wednesday night, I think, on May Day, on the 1st of May. And it was a lot of fun. We did it via Zoom. And of course, I have the resources here, and we used them, and it went really nicely. So we may be doing that some more. And I also recognize that we haven't had an antenna reception on our Discord server in a while. We will be returning to that, I promise. What else is going on? So the first, let's get the there's an elephant in the room. Okay, I I think you guys know that I have been using a Formlabs Form 3 Plus resin printer. There's a name for that. I think it's SLA. Don't ask me what it stands for. Somebody will tell us what it stands for. Printer to make the nozzles, the NOS products. NOS.gg is the page for that, and that's been super successful. And the resin I've been using is this gray stuff from Formlabs called Tough 1500. It is a polypropylene analog, and it works great. When I go to set up a session to print a bunch of parts, that usually ends up being, thank you, DBX. It's generally called stereolithography. I don't know who picked the letters, but SLA. When I go to print a tray or a build plate worth of NOSes, for example, they will print for on the order of 5 hours. It takes about 5-6 hours to crank those out, and then it goes into a bunch of finishing steps to clean the NOS really thoroughly before final cure. So it goes out of the printer into a pre-wash of IPA, isopropyl alcohol, a second pre-wash of isopropyl alcohol. Yes, we're trying to get it very clean. Into a ultrasonic cleaner of isopropyl alcohol, and then finally into final wash, where it spends the most time, about 13 minutes, and then into final cure. The final cure is the station that Formlabs sells called the Form Cure, and it applies heat and UV light to finish it off, and then it comes out magnificent. But that whole process is pretty significant, and it's pretty slow. Those 5 hours are mostly spent with a laser that draws the lines in Y, and then the whole laser moves in X. And that's how it does each layer. So it's been a great printer, and it's been very, has a lot of detail, and does a great job. They just came out with the Form 4. So what am I going to do, right? Ignore it? The first thing I noticed about the Form 4, which is on your screen, is they're claiming 3 to 5 times the speed. Well, it turns out that you could frame this a couple of ways, but they have completely changed their architecture. This laser, in Y and moving the optics in X was a big deal for them. It made some things possible. And one of the things it made possible was this very low force between the part and the bottom of the reservoir. So the bottom of the reservoir is actually where the resin gets cured as the light exposes it. And you have to get your cured plastic off of the bottom of the tray so that you can lift it up and get ready for the next layer. And the way they did that is that module that moved across in X actually pushed up on the plastic as it was writing it, and when it went by, that plastic would recover and peel itself off of the layer that was just cured. So they had a name for it, low force something, and it was pretty brilliant. So out comes the Form 4 printer, and I hear about this, I guess, a couple of weeks ago, and I watched the announcement video, which is on YouTube. I suppose I should link it in the description when we post. And it was pretty cool. they completely abandoned this technology that they worked really hard to develop. And now their gross architecture is pretty much like other printers on the market, in which they have a light source on the bottom, which they turn on and off for exposure. They have the reservoir, and they have the panel that they expose through, and then they have, the build plate. And you look at, and there's an LCD shutter. So there's an LCD display being used as a shutter to create the artwork, or to create the structure of the layer. And at first glance, you look at this and you go, oh, they just kind of sold out. They're just doing what everybody else did. On further examination, they took every step of the technology and really put some serious engineering into it. For example, the light source is of ridiculous power, and it's an LED array. Then there's a group of optics right above the LEDs, which collimates, that's their word, not mine, collimates the light and gets it going in the direction they want it to go. And then they have the LCD screen, which is not an off-the-shelf, LCD screen stolen from some computer display. It's an engineered LCD display. And then they did something super interesting. So I got on the phone with one of the Formlabs guys, and I basically started quizzing them as to what's different, why do they think I need this printer. Well, it turns out that I was worried that they lost this low, this peeling of the bottom of the reservoir off of the part as things move along, because things aren't moving along. Well, it turns out they use a puff of air to between the layers to separate the parts. It's kind of brilliant. I can't explain it super well, except to say that they addressed it. They also added a heater in the frame around the LCD so that the resin tank is heated. They also did a couple of other super cool things. I kept asking questions. The guy I had on the phone kept answering them, and it sounded really good. So here I am. I like the newest model as much as the next guy. But they proved to me, beyond the shadow of a doubt, that this thing was going to be 3 to 5 times faster to print than the old printer. And that had me very intrigued, because maybe not from a production standpoint, I could start the printer and make nozes and go to sleep, and then the next day, while I sleep, they get made. So the speed for production of nozes was not the biggest deal for me. But in an engineering situation where we're making a prototype, some of you know where I'm going with this, what we call P1, we know that P1 has a limited lifetime. How long does P1 last? Anybody? You in the back? How long does P1 last? Anybody? Correctamundo. 15 shakes. Josh got it. P1 lasts 15 minutes. That's my philosophy. K-Bonk says 15 seconds. That is possible. Sometimes it might last 15 seconds. But on average, P1 is good for 15 minutes. So if you can speed up the prototyping loop instead of waiting. So I'm doing a little prototyping for somebody right now. I don't think I'm at liberty to say who it is, except they're in the knife making industry. That's all I'm going to say about that. And it takes about 2.5 hours to do a run of the thing that I'm prototyping. Well, now it would take, a fraction. It'd take a fifth of that in order to get the prototype out and to do a test and see, did the last change help? It's pretty exciting from an engineering standpoint. So you probably realize what's about to happen next. I drive past Formlabs headquarters on the order of once a week to once every 10 days. I mean, I know I've been in there. I've gotten the cook's tour, and it looks like I'm going back. So Thursday, I'm going back in to talk to these guys and put my hands on the Form 4 and also bring a memory stick. Bring my memory stick and bring a couple of models, which we're going to print while I'm there. And that is pretty exciting. So if there's two models I want to bring with them and bring with me to them, and if the Form 4 does a really super good job on these models, and it does it as fast as they say it's going to do it, I think I'm out of excuses. I may have to pull out the checkbook. But we will see, and I will report back. They are not giving these things away. Okay, the Form 4 is listed at $4,500. And from a professional engineering standpoint, it's not bad. From a hobbyist, occasional user, buy it as a toy standpoint, it's a little dear. So we'll have to see what happens. Malteser says, "You're mistaken. They give those away, just not for free." You are correct, sir. Give that man a chocolate bar. Yeah, so we'll see what happens. If I smell a rat, I will continue to delay. It's not like I need it, but this may be a thing that's happening. So stay tuned. I'll give you a bit of German humor. Thank you. I appreciate it. It is definitely not for free. And of course, I said, "Hey, don't you know who I am?" Yeah, they didn't care. So that news will be coming this week, and I'll give you a full report. I also have a hypothesis I'm working on for improving the quality of the prints, which I'll save for another day because this is not intended to be a deep dive into SLA printing. But and I will bring back any wisdom that I gain on Thursday. So if you guys have any questions that you want me to take with me to Formlabs on Thursday, please let me know, and I will get back to you with the answers. The resins are the resins. They did say that they're reformulating the resins a little bit for the new printer to lower viscosity, which also got me very excited. But essentially, all the resins that you can get for the Form 3 is the same family as for the Form 4. So that is the answer to that question. I have to say that I was really impressed. I've been impressed with everybody I've dealt with at Formlabs. And this gentleman this past week was no exception. Okay, so if you guys have any questions on that, you can pop them into chat, and I'll do my best to see where that goes. So continuing on the lapping project, I had some really nice success, which I showed last week. I showed some measurements we made on surface roughness and stuff, but also acknowledged that we were absolutely not done with the recipe yet. And what I wanted to do in order to continue on the lapping lab and the Toolmaker's flat is to add my additional finer grits into the laps. Right now I'm running 3-micron diamond, and I intend to run 1-micron diamond and 1/4 micron diamond. So I I made a pile of laps this week, that the stock for which has been sitting on my shelf for months, but we finally got that going. Hey, welcome to Evils, who is reporting very late. Perfect cycling weather in Ghent, Belgium. Welcome, sir. Nice to see you. And I thank you, Evils, for keeping me company. We were live on the road on our Discord server in our voice chat, and it was kind of fun to be able to chat with folks. Greenwood asks, what is the frequency of light that Formlabs uses? Are the 3 and the 4 the same light frequency? That's an excellent question. I believe the answer is approximately yes, because they're not reformulating the resins for that reason, but I will find out. In fact, I'm going to start my list of questions, and I will report back. Excellent question. Especially if one was laser generated and one's going to be LED generated, there's definitely going to be a question about wavelength. So wavelength of light on my list. Excellent. So laps, I did the lathe work on 5 more blanks. There is a 6th lap, which is actually done. I have it here. If you're watching on video, you can see it. But if you're listening to this as a podcast, you just have to trust me that I'm holding a kind of heavy cast iron lap, which is pretty flat. Does anybody want to guess? And you guys from the Discord server are disqualified. Do you want to guess how heavy this is? This is a 6-inch cast iron lap of thickness 1 1/4 inches. And just for fun, how heavy is that lap? Anybody? We'll tell you what the prize is. So Unix Carbide is at least listening. Oni balloons. What is an Oni balloon? Is this a Japanese party toy? Do we need to bring you in live on video to explain this? All right. Nobody's guessing the weight. Let's see. Demon balloon. WidgetWorks says 160 ounces. Are you cheating? I think you're cheating. Okay, so that's about right. This is 9 pounds and 6 ounces. So the reason I bring this up is that when you've got the conditioning lap on top of the working lap and you're moving it around, you're moving around something that's 9.5 pounds or thereabouts, over 9 pounds. And that gives you a feel for what those forces are like. So you're not pushing down on these laps. They have their own gravity that they bring with them. So I made up another 5 on the lathe. Next step for them is to go over to the grinder. They will get ground flat. And then after that, they go over to the CNC mill, and we get the grid pattern put in, including what I affectionately call the Renzetti groove, which is the outer periphery, which is closed so that we don't dribble our diamonds all over the table. And that, I believe I still have the G code for that in the milling machine so that I could pop it in. I remember your video, Robin. That was something else. Robin says, try 135-pound lap on a surface plate. You know what? I'll watch you. I don't have room, but that sounds pretty like a pretty good workout. Michael Juan says, can you ask why they chose LCD over DLP other than cost? Yes, I can. And I have no idea what the answer is. But I have your question. on the list. They acknowledge that they didn't use the highest resolution thing on the market because reasons. They have reasons. So if it's a resolution fight that you're looking for, you're not going to get one with them. It's like, yeah, we get that. Also, they showed, I know I'm jumping around here, but they showed pictures of models that they've printed on the 3 Plus and on the 4 next to each other in some detail. Also, tested.com did a review. Norman Chan did a great review, and the difference is not significant. So I will find out. Greenwood AG asks, are the groove bottoms a V groove or round groove? They are V groove. If you watch the video I did on setting up for hand lapping, I made my own cutter, and it is a V groove cutter, and it does have a flat tip on it. I don't remember the number, but it's basically V groove with a small flat on the bottom. And like I said, the program I think is still sitting on my memory card. I may be able to just get the vise set up, get everything aligned, and hit the button, and we'll be good to go. So that's the laps, and because they get surface ground, top and bottom, they lap in quickly to being ready to work, and that's very different from trying to create your laps using the Whitworth method, which was an excellent demonstration by Tom Lipton. But if you grind them in, it's almost like cheating. You're most of the way there. So this also brings up a question, which is not a secret. I put that in the thumbnail, and that is, do we productize this? I had several people asking me about, if they're for sale. Greenwood asks, have you determined an ideal groove depth? And the answer is no, I have not. I think I picked 30 thousandths as my groove depth, and I'm open to input on that, but it seemed to work really well. And I did not determine an ideal groove depth. If you have some input on that, I'd be open to hearing about it. Yeah, Evils wants to optimize the depth and the angle of the groove. This is a very slippery slope. And once you're getting good results, the difference between science and engineering is that in engineering, once you get good results, you're done. Now he wants to know the angle of the slippery slope. No, we're not going there. So a bunch of people asked me if Kinetic Precision was going to sell the lapping plates. And the answer is a definite maybe. So enough people asked me that I will go through a pricing exercise, and I'll price it. And after you get off the floor, you may have a different opinion of me, but we'll see. The material wasn't super cheap, and it sees 3 different machines, so there's some costs there. And you could make it yourself, but I can understand wanting to buy it and save time and not have to go through the exercise. So I will let you know, but I'm open to your input. If you guys say, yeah, I'd be interested, please tell me. It gives me an idea of who would be interested. This is ductile cast iron. I buy it from McMaster Carr. If there was a reason to, if volume was high enough, we would get it from another supplier. But it's pretty nice coming in from McMaster Carr, cut to length, and ready to rock and roll. So that's the lapping plates. The ability to quickly change from one size to another size and have everything compact and neat has proven to be very useful. Robin is reporting, if the groove is too deep, all of the slurry runs into the grooves. If it's too shallow, they will disappear too quickly. 90 degrees or greater groove angle will draw slurry away from the groove toward the surface. 90 degrees or greater. So I'm not using 90 degrees. I'm using 30. I think I made a 30-degree cutter. I'd have to go back and look at my drawings. No, this is pretty steep. So I don't remember. The answer is I don't remember. But I will revisit that. So thanks for that input, Robin. I knew there had to be some sort of an optimization here. And you and I will talk before I commit to the rest of these plates. But I have to say that the plates were behaving pretty nicely. So DBX just posted the ISO standard for cast iron surface plates, but does that include lapping plates? Inquiring minds want to know. We'll find out. Also, in the chat before we started, Paul Morley was bringing up a trick that Tom Lipton showed, which was using a aluminum tape on a surface plate as a substrate for lapping grit. And in fact, it's a pretty good trick, but I think we'd call that a coarse application. I mean, you can get pretty good results, but what we're doing here is we're trying to really control that curvature, and you're not going to get that control of curvature by putting an adhesive tape onto a surface plate. Because the crazy truth is that you need a convex surface in order to to lap something flat. So you have to be able to control that surface shape, and putting the adhesive aluminum onto a surface plate is pretty darn flat, but it doesn't give you the control you need if you're getting down into the weeds. Evil says, he has a question. What is the lifetime of the Form 4's LCD? They actually had a number for me. I didn't ask the question, and they had the answer. And I'll get that for you because I don't remember the exact answer, but the practical result was it's the last thing that's going to die on the printer. I shouldn't say that. That was the light source was the last thing that was going to die on the printer. It was going to be long enough that I would never have to worry about it, but I'll find out for you. Actually, I could commit to next week's PFG.Live. I will have all the answers, so I'll make sure that all the questions that you guys send to me, I will get answered. Interesting. So, in a Discord discussion this morning, to tie in all these things, there's some information that WidgetWorks dug up. He put it into chat. Okay, so Robin's put an address for American Iron and Alloys in the chat, and I think he's going to tell me that this is a good place to get the lap material. Let's find out. When you get stuff from McMaster-Carr, we joke about it a lot. You might have seen some joking about it this week. You can get anything from McMaster-Carr, and most things that you can get from McMaster-Carr, you can have it tomorrow. But it's not going to be, especially when you're buying stock, metal stock, it's not the cheapest price around. So let's just understand that. When we talk about getting stuff from McMaster-Carr, they're going to stand behind what they sell you. They're going to get it to you tomorrow. They're going to take care of you, and you pay for it. And I'm happy to pay for it. But if we get into this and you guys start ordering, lapping plates, then and the volume goes up, we will absolutely go to a supplier and get a better price. But enough of that. Why don't we invite Robin in to speak and let him tell us what his ideas are? Let's see. Please stand by. Robin, you are on the air.
Okay. Can you hear me?
I can hear you loud and clear, sir. No video, but good audio.
Okay. Oh, I can turn my camera on. Not that anybody wants to see me, but American Iron and Alloys is extremely good, extremely competitive pricing. They carry gray, they carry multiple varieties of ductile. Ductile comes in different tensile strengths, yield strengths. And ductile works fine as a lap too. There probably is some difference. Ductile's a lot nicer to machine as far as that goes. But you could call them up and say, I want X number of round pieces sawed at this length, or you can just get a chunk. But you can also get rectangular stock. Or you can say, I often say, I want a piece that's 6 7/8 by 3 7/8 by 9, 2 pieces, ductile, and that's it. And they send back a quote, and their prices are really, really good. Way better than the other major continuous cast supplier, whose name is evading me right now.
Oh, I know who you're talking about, too.
Durabar.
Durabar. That's it. Yeah.
Yes. Yeah, way better than them on pricing, and really good place to work with, because I use a lot of ductile iron in spindle manufacture. So, yeah, really good place.
Neat. So my normal go-to supplier is Yard Metals, and I haven't asked them, but they might be able to get it. I know that some suppliers, if they have just tons of, like, for example, cast customers, they're a good place to go for cast. Similarly for aluminum, etc. So I've had good aluminum supplier, easy, just like everything you described. Get it cut any way you want. But these guys sound like they do their cast stuff. DBX just posted a picture of a radial lapping plate. Is that where'd you steal that from, DBX? That looks pretty cool. And if that's what you want, I'll supply it. I want to be your McMaster car. Lapping plates from HK Founders Limited. Interesting.
That's for a rotary lapping machine.
Yeah.
As opposed to hand lapping. Yeah.
Yeah. I promise I am not getting into mechanized lapping. I promise.
That's funny.
Yeah. Okay. You are starting trouble, All right. Well, thank you, sir. Anything else you want to comment on today? What color would you like your?
I'm in the process of doing another set of 24 keyway gauges, and I'm actually doing the YouTube video in the process. So showing dicing them out of tool steel blanks, surface grinding them, lapping station, and lapping technique, and reading bands and all that.
I'm sitting on the edge of my seat waiting for your video. There's some particular topics I'm interested in, and I've kept my mouth shut about it. So,
and I am going to be using that third technique, the third plate technique. So
the dreaded third plate. Okay. Well, thank you, sir. You're a gentleman.
Okay.
Thanks for being here.
Yep. Well,
bye.
Yep. Thank you.
All right. And by the way, if you join us on our Discord server and you have something clever to say, we will be happy to have you come in and do the same thing. So Tucker says that picture that DBX posted of a lapping plate looked like FEA software. So isn't that exciting? So we're going to see some new information from Robin in the not too distant future. I'm looking forward to that. I've seen pictures of the gauges he's making, and they're gorgeous. So yeah, much to learn. So we'll keep everybody posted. I will say that I went back to this was as a result of our conversation on Discord this morning. Some I think QD Smiths. No, who brought up the yeah, I think it was QD Smiths brought up the 1-year-old video from Adam the Machinist on using 3D printing to help in making laps, pitch laps, which I thought was excellent. So I look forward to crossing the streams and introducing some 3D printing tools into doing some sort of lapping. But I'm going to wait. I'm going to wait for Robin to teach us before I jump into that. Also, the supplier of pitch for making pitch laps, which I know some of you don't know what a pitch lap is, and I don't want to jump into that right now. But Robin had given it to me a while ago, and then we came up with it again today. Looking for it. Oh, it's in a different stream. Robin, if you could just punch that into chat, if you're not already doing that. So pitch, the telescope guys, including now Adam Ballog, know about pitch material for lapping optical components, and pitch is a very it's the best way to put it is it's an extremely viscous liquid. So it's like tar. If you ever see, asphalt on the road, it's sort of the same kind of thing, of course, much more controlled. And there was a company that we can get relatively small amounts from. I will put that information into an easily accessible place. There it is. Thank you. Firsthanddiscovery.com is the company, and they sell small quantities of the, I'm going to butcher this name, Google's pitch, which is a very well-known pitch, except that you have to buy big quantities usually, and these guys have it in small quantities. I have never made a pitch lap. Adam has. Others have. So one of these days we may get into that. Yeah. So we're learning as we go here with respect to lapping. $10 for a half a pound. That's and a half a pound is going to last you a reasonable amount of time. I mean, that's a lot of material. So that's not bad. That's pretty cheap to go start playing. So we're crossing the streams. We're stealing ideas from the telescope makers. We're going to use 3D printing and incorporate our diamond lapping techniques and end up with something cool. So I'm looking forward to doing that. And then we could finish up the recipe for our Toolmaker's flat, because really this is sort of the last piece of the recipe. And then P1 will be over, and we'll start on P2 and P3. I have a couple blanks already lathed, and I did that just to upset some people. They're already lathed, and they're ready to go into heat treat. But I'm waiting until we finish the whole chain of recipe and recipe tuning to do that. So that's the story on the laps, and looking forward to doing more of it. It's a lot of fun. I was talking to a friend of mine 2 weeks ago. Yeah, 2 weeks ago. Adam, another Adam, still yet different Adam. Adam from MHM Machining. Adam Brunette. And Adam makes these really cool plastic Delrin parts as part of testing apparatus for fiber optic instrumentation. Cool stuff. But he's got into a situation where he thinks he wants to automate, and we started talking about robots. So many of you have seen the I think it's the UR robots. Pearson Work Holding has been using UR robots for loading and unloading machines. They had mixed experiences with it. But in general, I think the term of art is a cobot. So something that's going to load a machine, unload a machine, start a cycle, etc., is what Adam's looking at, and it's what we've seen on various YouTube videos. And I started thinking about this, and I started asking the question: when do you invest in something like that? Because I think you have to look at the whole equation. So if you take my situation, for example, I'm a one-man band. I have the things that I manufacture are done in relatively small quantities, and they're high precision things that we want to make sure come out right on each one. Should I get a robot? Well, my answer to that is absolutely not. But Adam's answer to that, because of the quantities that he's making, is yes. And a while back, we talked about, WidgetWorks says, maybe a floor sweeping robot. That's a robot I can get behind. A while back, we talked about what's the ideal cycle time for a machine in the shop. And I offered the opinion that 1 hour is a good cycle time. So let's take a look at that. I know in Adam's situation, I'm just going to arbitrarily say that his cycle time is about 5 to 10 minutes for a part. So if he's making 100 parts or 1,000 parts, he needs an operator standing there because it needs attention every 5 to 10 minutes. And in 5 to 10 minutes, what can you do in that interval other than stand at the machine? And the answer is very little. However, if you have a cycle time of an hour, or in his case, maybe even 3 hours, you can get a lot done in parallel with that machine running and still be a one-person operation. And I think that's the key. And I know Adam, and he's got a lot going on. he's if, for all practical purposes, a farmer, in addition to being an outstanding machinist and an outstanding IT guy. So in his case, it's like, how do I get the cycle time up to an hour? Well, you can imagine, make this a milling operation and palletize it and, blah, blah, blah. But he has a limited space. So going to a big mill with lots of pallets might not be the best answer. But a lathe that gets loaded and unloaded with a robot might be the best answer. So he was showing me some of the data associated with how much does it cost? Who do you get the parts from? Who do you get the robots from? And it was pretty interesting. I do think there's a danger, and I think there's a danger in over automating. And what do I mean by that? I mean, you could spend an awful lot of money. So one of these UR robots was on the order of $50,000. So setting up one of these cobots in front of a milling machine, which I think, sorry, I was trying to remember if John Grimsmo ever discussed a potential robot, but I think I might be mistaken. But you have the cost of the machine. You have the cost of programming. You have, of course, maintenance costs, and you have risk costs. Because if you want to screw something up quickly and and in great quantity, a robot's a great way to do it. Excuse me. So you can go overboard unnecessarily. So, for example, on my grinder right now, I could load. Yeah. So Tucker correctly says that Grimsmo's robot is the Kern plus the Eroa, and I think that's awesome. And our machines, by definition, our CNC machines are robots. And that's not really what I'm talking about. I'm talking about an external robot that's going to feed that machine, which you could argue that that's an artificial constraint. But the Eroa is a fixed piece of gear that is attached to the machine, so it's kind of a different animal. Uh, Michael Juan says the UR robots joints wear out pretty quickly when you have them at full extension with the rated payload, but they give them almost free to university research. Well, they don't give them free to their customers, I'll tell you that. It was pretty expensive. And WidgetWorks correctly says bar feeder on a lathe with a parts catcher is the simplest robot add-on. I agree. And if you have the opportunity to do that, and your parts are all lathe parts, that is the way to go. I don't remember who said it, but it was that a lathe with a bar feeder is the closest thing to a money printer that you can get. Yeah, it was Saunders, right? Oh, wait. Somebody says it's Jay Pearson. Somebody says it's Saunders. Maybe it's both. ¿Por qué no los dos? Yeah, WidgetWorks says, I make a ton of mill parts on the lathe. And I make lathe parts on the mill. We should get together. The B200 balancing rings look like they should be lathe parts, but they're made on the mill. So I think there's a line in either direction. I won't stand and run a manual grinder anymore. That would just be a complete disaster. On the other hand, if you said to me, we're going to put in a UR robot to load and unload your grinder, I know too much, and I would say that's probably not going to end well. So obviously there's an optimum in there, and I'm pretty happy with my situation where I can set up the grinder and walk away for an hour, and then come back. I think that's a pretty good scenario, and I think similarly on a mill or a lathe. Well, a lathe with a bar feeder is a special case. That thing could literally run for days, properly set up. Tucker is correctly pointing out process reliability. He's waving the process reliability flag. And I agree with you. You have to do a lot more. Here's a statement that's going to get me in trouble. You have to do a lot more and spend a lot more money in order to have sufficient process reliability that something will run for a week without a human touching it. I don't think anybody would argue with that. I don't think Grimsmo would argue with that. He's very proud of the weeks that he loads up that Kern and that Eroa and it just runs. But look at, add up the other side of the spreadsheet for how you get there. And that's not easy. So if you're a small shop and you're making some specialty stuff, which is really most of our audience, there's a line somewhere, and do you cross it? And if you do cross it, what's the risks? What's the business risks? What's the, what are the chances that your market's going to dry up? Evils correctly pointed out earlier this week. I said, gee, I have a nice recipe now for these lapping plates. Should I start selling them? And he made a good point, which of course is correct, which is, well, if you have a good recipe, you could just start selling them and then make them as they get ordered. Same thing for the NOSes. I have a very, very tiny inventory level, and as orders come in, I make them. Same thing for the PFG Stones. As orders come in, I make them with a very, very tiny inventory. Tucker says, that is absolutely correct. You need a good process before you can truly automate, and not just making the parts process. QA afterwards to handle the throughput. Excellent. So that's like a square law problem. You not only need to be able to make the stuff, you need to be able to measure the stuff and test the stuff and do the QA on the stuff. So these are interesting questions. I don't have answers. If you were tuning in for answers, I'm so sorry. But I believe you can, there is a danger of over automating. And there's also a danger of under automating. My shoulder, my left shoulder would be a complete wreck right now if all of the grinding that I've done in the last year was done manually. That would be bad. So clearly, under automating isn't good either. So give it a thought for what you're doing. If you're just having fun and you want to buy a robot because it's fun, go for it. I'm not the one that's going to talk you out of that. But if you're trying to make money, and certainly if you're trying to stay married, I would be careful with how much real estate you use for that kind of thing. So that's what I got. I want to give a shout out to my kiddo Sam, who finished up the school year at the School for the Museum of Fine Arts, and as part of a final project, it's not done yet, but made significant progress on building a suit of armor of Sam's own design, and it's pretty cool. But the very interesting thing is that it's made out of aluminum, which sounds weird, except that in medieval times when, suits of armor were worn, aluminum was not even known. And when aluminum was known, it was some of the most expensive, rarest metal on the planet. So I get a huge kick out of the suit of armor made out of aluminum. I just think it's neat. Let's see. Josh says, go Sam. I'll pass that along if Sam's not listening. Widgetworks says you just need to make sure that the robot can do house chores and the marriage will be fine. Good point. Tuck says, perhaps we could have a separate discussion /live on the thought process to automate any process. And go Sam. Thank you. It's a good idea. So in the after show, we'll talk about that. Now, I know, DBX says it applies to software as well. Really? Software is just ones and zeros. I don't understand. Just kidding. So, you are watching the PFG Live, and the PFG Live comes to you via YouTube. And on YouTube, you could be a subscriber or you could not be a subscriber, but you could still watch it and enjoy it. I know that 2/3 of you, yes, you in the back in the green sweater, 2/3 of you are not subscribed. Here's a secret. Down in the corner of the screen, right there, it says PFG.Live. Do you know what that is? That's actually a URL. If you go to your browser on your computer and type PFG.Live, it will take you directly to the YouTube page where all of this is archived. But more importantly, right in front of your nose on that page is a big button that says, what does it say? Correct. Subscribe. So if you hit that button, you can subscribe and get notifications. K-Bonk, I will pass along your question to the Sam. CJ Stevens says, you beat me to it this time. Yes, I was thinking of you. I knew you'd remind me. And CJ Stevens says, hit that like button too. That's also appreciated. Here we go. Robert Simpson says PFG Stones plug using the small one right now. There he is. It's an actual PFG Stone in the wild. So if you do need something flat, go to pfgstones.com and check out PFG Stones. We had NOSes were going crazy this week. Those are going out the door. What else is going out the door this week? Oh, balancing stands. Interest in balancing stands. So that's flying out the door. You know who you are. And balancing rings are going out the door. So we're staying on top of everything. Maybe losing a little sleep, but not too bad, because I still have to keep my other clients happy. Well, guys, we hit the top of the hour. Thanks for being here. A lot of fun. Every Sunday, we're here at 1400 Eastern Time. Right now, that's 1800 UTC. Right here on YouTube Live and in our Discord server. We'll be in the after party roundtable right after this, and you're welcome to come join us. And if you have any questions, somewhere on the pfgstones.com site, you'll find a contact button, and you could send me a message. Get flat, stay flat, and we'll see you guys next week. Doink, doink.